Lesson 1.6 is about the nature of the roots of a quadratic equation. Remember, in the previous 4 lessons, we have learned how to solve for the quadratic equations, the roots, through extracting the square, through factoring, through completing the square, and lastly, the use of the quadratic formula. You can use any of the 4, but there are some conditions to meet. Like, for example, if you only have a and b, like the x squared and the x, you could use extracting the square roots. That's the easiest. If the 3, like the x squared, the x, and the constant term around, and it's factorable, then it's easier to do with factoring. But if it's not factorable, you can go for completing the square, and quadratic formula works for any of these conditions. So it's up to you to master 1 or 2 methods. Like, for example, in my case, I master factoring and quadratic formula. I disregard the completing the square because anyways, it can be solved with quadratic formula. So it's up to you to master 2 or 3 of those methods, and better if you will master all 4. Now, today, we'll talk about the nature of the roots. How do we describe the roots of quadratic equations? And to start, let's recite our memory verse for the day. Our memory verse is found in Revelation 22, verse 16. It says, I, that refers to Jesus, am the root and the descendant of David, the bright and morning star. It's found in Revelation 22, verse 16. So if we say root in the Bible, root means being the child or being a descendant of a big family. So that is the root. That's why you noticed once we will have attend reunions, we are drawing family trees from the roots to the fruits. And today's Meet Your Targets is very simple. At the end of this lesson, you'll be able to characterize the roots of a quadratic equation using the discriminant. And let's start with our venture activity. Okay, let's do the chat box because I think it's easier for us. What will we do? Let's identify if the square root is real or imaginary. And if it's imaginary, remember the I. And if it's real, we need to identify if the root is rational or irrational. Ready? In the chat box, everybody prepare your chat boxes now. Let's start. You just say imaginary or real. Ready? This is the first one. Square root of negative 15. Imaginary or real? Very good. It's imaginary because of the negative 1 inside. Next, for L, square root of 7 over 8. Real or imaginary? Very good. It's real. The next question, is the square root rational or irrational? Ma'am, what is rational? If you say rational, you can write the square root as a fraction of 2. Like example, if the square root is 2, that is 2 over 1. If the square root is 3/4, that is 3/4. But for example, if the answer is, you could not narrow it down to this one, like it's still square root of 7 over 8, we call it irrational. So this is irrational. Very good. Next, square root of 24.5. Real or imaginary? Very good. It's real. How about rational or irrational? Very good. It is irrational, IR. Next, square root of 5 over 12. Real or imaginary? In the chat box. Very good, it's real. Rational or irrational? Very good, it's irrational. Next, square root of 289. Real or imaginary? Very good, real. Next, rational or irrational? What's the square root of 289? Plus and minus 17. So it is rational. Next, square root of 25, real or imaginary? Very good, it's real. Rational or irrational? What's the square root of 25? Plus and minus 5. So it is rational. Very good. Next. Here, A, square root of 15 over 9. Real or imaginary? Very good. It's real. Next, rational or irrational? There's no specific for square root of 15. So it is irrational. Next, letter T. Square root of negative 21 over 9.
Just wait.
Real or imaginary? It is imaginary. And remember, if it's imaginary, we don't need to classify it as irrational or rational, because rational and irrational numbers are real numbers, never imaginary. Next, the last one, square root of 35, real or imaginary? Very good, it's real. How about rational or irrational? Oh, that's great. We say it's irrational. The answer is still square root of 35. Very good. You are really doing great in our class today. And for sure, you'll find the next lessons very easy. Yes, AP, you have raised your hand.
How do I know if how can I tell if it's real or imaginary, teacher?
Oh, remember, let me use my pen, like this one. If the one inside is a negative number, then it's imaginary. If the one inside is a positive number, then the answer is it's real. Again, the negative and the positive inside will only apply to square roots. In the next quarter, we'll be talking about the radicals, and it's different. It does not apply for all. It only applies here because our index is 2, or the square root.
Okay. And how can I tell if it's rational or irrational?
Example AP, square root of 25. What's the answer? Plus and minus 5. This is a rational number. Another, square root of 4 over 9. What's the square root of 4? 2. The square root of 9, 3. So it's still rational. But example, we have square root of 6. Is there a rational number that's a square root of 6? There's none, right? It's still square root of 6. Therefore, it is irrational.
Oh, okay. Thank you, teacher.
Oh, you're welcome. Now, let's go to the main lesson. Our main lesson today is about the discriminant. And let's review the quadratic formula. Yesterday, you have the quadratic formula, right? In the quadratic formula, this one inside, the b squared minus 4ac is called the discriminant. You might ask me, ma'am, what is a discriminant? A discriminant, I told you, it's the b squared minus 4ac minus 4ac. What's the rule of the discriminant? The discriminant will be the one to describe the nature of the roots. So for example, my discriminant can be 0, it can be positive, or it can be negative. By just looking at your discriminants, you will have an idea whether the square root is imaginary, real and rational, or real and irrational. Let's have an example. Here's the nature of the roots that we will have. There are 4 classifications. First classification. Remember, we need to solve for b squared minus 4ac. If our discriminant is 0, it means that the roots are real and equal. For example, if the discriminant is 0, then the roots can be real. Example, 5 and 5, and they are equal. So usually we write it as 5 with multiplicity 2. The next one, if the discriminant is positive and it's a perfect square, then it means that the roots are real, rational, and not equal. For example, if my discriminant is 16, and remember 16 is a perfect square, then my roots are real, rational, and not equal. Let me give an example of roots that are real, rational, and not equal. 5 and negative 5. If these two are the roots of your quadratic equation, then they are both real, they are both rational, but they are not equal. They are not the same. Unlike the first one, when the discriminant is 0. The next, if the discriminant is positive, but it's not a perfect square, then our roots are real, irrational, and not equal. Example, if my discriminant is 15, so it means that roots are real, irrational, and not equal. Let me give you a pair of roots which are real, irrational, and not equal. Example, we have 5 and square root of 5. Or you have 5 plus square root of 2 and 5 minus square root of 2. These two are real. These two are irrational because they are the square root of 2 and they are not equal. But if our discriminant is negative, then the roots are not real. We call them imaginary. Example, if the discriminant is negative 15, remember, you place it inside, right? Square root of negative 15, that's imaginary, right? So it means that our roots are imaginary. Yes, Taj, you're raising your hand.
Mom, I just to say that Shello told us in our GC she's having a hard time working with the Zoom. It's not cooperating well with her right now.
Oh, it's Tatiana, right?
Yes, ma'am.
Thank you for that one.
You're
I'll
welcome.
give me a minute first. I'll just make a reply. Okay, now let's continue with some examples. Again, Remember, if the discriminant is 0, the roots are real and equal. If the discriminant is positive and it's a perfect square, the roots are real, rational, and not equal. If the discriminant is positive but not a perfect square, the roots are real, irrational, and not equal. And lastly, if the discriminant is negative, then the roots are imaginary. Let's try an example. Ready? Here. First, we need to identify the values of A, B, and C. So our A is 2, our B is -5, our C is -3. Next, let's substitute it to our formula. B squared minus 4AC. That's -5 squared minus 4AC. -5 squared is 25. Again, when a negative number is raised to an even exponent, the answer is positive. Next, negative times negative. Oh, there are two negatives. So that's plus. 4 times 2, that's 8. Times 3, 24. So our D is equal to 49. Now, it's positive. Is 49 a perfect square? Yes, right?
Yes.
Very good. What's the square root of 49?
7.
7. Very good. So how do we describe our roots? It's positive, so it's real. It's a perfect square. It's rational. Sorry for my handwriting. And the last is they are not equal. That's it. Let's go to the next one. Ready? Tell me in the chat box, what are the values of A, B, and C? What's the value of A, B, and C? Where's my pen? Wait, give me a moment first. There. Now, the value of A is 1. Very good. The value of B is, oh, where are you? Are you looking at a different one? -1. The value of C is 2. So let us substitute. Ready? -1 squared minus 4AC. You know what? That's my technique. This one becomes negative. So -1 squared is 1. Only one negative, so minus. 4 times 1 is 4. Times 2, it's 8. So 1 minus 8 is -7. Tell me in the chat box, how do you describe the roots of the quadratic equation? Very good. This one is negative, so it means it is imaginary. Very good with that one. Let's go to the next one. Did I skip? Oh, yes, I skipped one number. There. Ready? Tell me in the chat box, what's the value of our A, B, and C? What's the value of A? You need to master this. Okay, that's 1. B is 5. C is 3. Very good. Let's substitute it. B squared. 5 squared minus 4AC. So we have 25 minus 12. That's 13. Okay. In the chat box, describe the roots. How do you describe the roots? It's positive, so it's real. It's not a perfect square. It's not 0, right? So they are not equal. It's not a perfect square, so it's irrational. Next, I think Ahava, you're doing the other one. No worries. Now let's go to the next one. Here, in the chat box, tell me the values of A, B, and C. A, B, and C. This is the one that Prince asked yesterday. What's the values of our A, B, and C? Oh, A is 1, very good. Then B is -5, and C is 0, very good. So let's have the formula. Substitute -5 squared minus 4AC. Oops, there's a 0. So this becomes 0. We have 25. How do you describe the roots? Ready? It's positive, so it's real. It's not 0, so they are not equal. Then it's a perfect square, so it's rational. Yes? Now let's go to the last one. Ready? Here. In the chat box, let me know the values of A, B, and C. Ready? Very good. A is 1, B is 2, C is 1. Let's substitute. 2 squared minus 4 times A times C. 2 squared is 4 minus 4 times 1 times 1, it's 4. So our discriminant is 0. How do you describe it? A 0 discriminant. They are real and they are equal. Very good. The roots are real and equal. That ends. As easy as that one. I know you could get a good score in your module and in your online quiz today. Do you have any questions? Raise your hand.
No.